Welcome back to Quadratic Formula Moment. Today we're going to look at the quadratic formula and the discriminant. Our last lesson we worked with the quadratic formula and my neighbor's cat singing that haunting song, but it was so helpful in remembering the quadratic formula. And today we're going to tie down the discriminant and how we can use that. All right, so the quadratic equation can have one, two, or no real number solutions. Before you solve a quadratic equation, you can determine how many real number solutions it is by using the discriminant. Okay, the discriminant is the expression under the radical sign in the quadratic formula. So what's marked in red here. So the discriminant of a quadratic equation can be positive, it can be 0, or it could be negative inside that square root. And depending on what those are, it's going to tell us about the number of solutions. So if your discriminant, when simplified, is greater than 1, then you know that there's going to be 2 solutions. Like for instance, in this equation right here, when you simplify this, you're ending up with 8, which is telling us the square root of 8, kind of a plus or minus. So plus or minus square root of 8 is going to give us 2 solutions. And the second equation here, when we simplify this, we end up with 0. And again, that's the discriminant, so it's inside the square root sign. So the square root of 0 is going to be 0. So there's only one solution for that one. So if your discriminant equals 0, then you know that you're looking for one solution. And if, in this particular equation, b squared minus 4ac, if it ends up being less than 0, like for instance this equation, when we simplify it out, we end up with negative 8. Well, plus or minus the square root of negative 8. Negative 8 is a non-real number. In that case, we would say that there's no real number solutions, because we don't have anything right now that you've worked with that is the square root of negative 8. So in this process here, we're going to be looking at the number of solutions. Okay, so let's use the discriminant to determine how many real number solutions does this equation have. I need to adjust it so I can use it. I'm going to change it. I'm adding 5 to both sides. And now I'm going to call on my neighbor's cats to bring up my quadratic formula. Cue the cats. Okay, so the cats sing, and I'm looking at just the discriminant here. The discriminant tells me that it is negative 3 squared minus 4ac. And when I simplify that out, I get square root of negative 31. So that tells me that there is no real number solutions for that quadratic equation. All right, why don't you try it? Press pause and you work it out. Again, get the discriminant and let it tell you how many answers you're going to get. Pause. All right, I end up, when I simplify my discriminant, I end up with square root of 193 plus or minus, so that tells me that this will have 2 solutions. For B, if A is positive and C is negative, how many real number solutions will you end up with? Well, in this case, my first term here, because I'm squaring it, it's going to push it positive, and I'm subtracting, so if anything in here is negative, for instance, my C term, that will push it positive. So in this particular situation, it will be greater than 0, which means that it will have 2 solutions. All right, now let's look at another concept is there's so many methods we have for solving quadratic equations, finding those x-intercepts, and how do you know which one to use? Well, we use the method of graphing, if you do have a graphing calculator handy. It's kind of nice for that. You use square roots if the equation has no x term. So keep an eye on that one. So it's talking about that second term. If it's missing the b term or that second one, then you can go ahead and just use square roots because that'll solve it out. You want to use factoring if you can factor the equation easily. If it looks like it plays out real nice. You want to complete the square if the coefficient of x squared is 1. But you cannot easily factor the equation. So if it can't be easily factored, you go ahead and complete the square because that'll get your answer. And then you want to use the quadratic formula if the equation can't be factored easily or at all, if it's tricky for that. So let's try that out in a couple of these. Which method would you choose for each equation here? You can speed through these. I'm going to go ahead and solve them out though, just to continue to see some more examples on this one. So for this one, we would use the square root method, because there is no x term or none of that second term. So I would do 3x squared minus 9 equals 0, and I would divide, well, actually, before I even do that, I would add 9, there we go. Then I'm dividing by 3, and I put x squared equals 3. I can do square roots. So x is going to be plus or minus the square root of 3. So I'm noticing there's none of that. There's not that x term or that, there's no b term. So let's look at this guy right here. X squared minus x minus 30 equals 0. On this one, I would definitely go ahead and do some factoring. It looks like it is easily factorable. And let's take a look at what that means. I'm going to go ahead and see, okay, what times what gets me 30. That when I add them together, I just get x. And I found out that it's 5 and 6, but I need to end up with a negative here, and so it's going to be my negative 6. So that gives me x plus 5, x minus 6 equals 0. So x plus 5 equals 0, x minus 6 equals 0. So I'm going to end up with x equals negative 5 or x equals 6 as my solution for that one. For this C, I'm going to look at this one and whoa, not easily factorable. I can, what times what gets me to 17? 6 is not prime, so I'm going to go ahead and use the quadratic formula for this one. Let the cats sing their song to me. So I'm going to go ahead and use that. So negative 13 plus or minus the square root of the b term squared minus 4 ac all over 2a. I simplify that and I have negative 13 plus or minus the square root of 169 plus 408 all over 12. And I want to simplify that out. And I end up with negative 13 plus or minus the square root of 577 over 12. So that gives me my two equations that I'm working with. So it's negative 13 plus 24.02 over 12, or negative 13 minus 24.02 over 12. And I end up with, when I simplify that, x equals 0.92 or x equals negative 309. All right, so my solutions for this one, which is 2, and I saw that in my discriminant right here, that there's going to be two answers in there, negative 309 and 92. Let's look at this guy here for D. For D, I could use the quadratic formula, or I could complete the square for either one. Okay, I'm actually going to do both. So if you don't want to hang around for this one, you can speed up or whatever you want to do. So I'm going to complete the square. For this one, I'm going to take 5x squared minus 5x equals a negative 3. I'm going to figure out what my c term is over here. So I got to use my, remember my b term, half of it squared, which means I need to add 6.25 to both sides to get me my perfect square. End up with, and I take negative 3 plus 6.25 and end up with 3.25. And I end up with an equation x minus 2.5 squared equals 3.25. And when I square root both of those, I end up with x minus 2.5 equals plus or minus the square root of 3.25. And so, I'm running out of room. X minus 2.5 equals 1.8, or x minus 2.5 equals negative 1.8. And when I add 2.5 to both sides, I end up with x equaling 4.3, or x equaling 7/10. That's if I complete the square on this one. If I do the quadratic formula on this one, I can see that I'm going to take negative 5 plus or minus the big square root of my b term squared minus 4ac all over 2a. Simplify this, end up with 5 plus or minus the square root of 25 minus 12 over, not 12, over 2. So simplify that, I end up with 5 plus or minus the square root of 13 over 2. My discriminant is 13, which is greater than 1, so that's going to tell me I'm going to have 2 solutions on this one. And I will. So let's work the 2 out. So I will have 5 plus 3.61 divided by 2, or 5 minus 3.61 divided by 2. Now if I simplify those, I can see that x equals 4.3, or x equals 0.695. Ooh, another one. Goody. All right, let's take a look at this guy. So negative 16 and 21. This guy is, yeah, this one's a tricky one to factor, so I would use the quadratic formula to work this guy out. Gives me a chance to do it. So I'm going to give this, oh, this guy had some big numbers on it. Oh, that's the negative b, okay. Plus or minus the square root of b squared minus 4a times c. Oh yeah, this is going to be a big one. Divided by 2 times my a term. Right. If I simplify this out, I see 50 plus or minus the square root of negative 50 squared is like 2,500 plus negative 4 times negative 16 times 21. We'll get, I did this one earlier. I'm not doing that one in my head. And that's all over negative 32. When I simplify all that out, I end up with 50 plus or minus the square root of 3,844 over 32. And this is greater than 1, so I'm going to have 2 solutions. That actually equals 62. Who would have thought this? 62 squared is 3,844. What a quinky dink. Okay, so let's go ahead and find our 2 answers. So 50 plus 62 over negative 32, or 50 minus 62 over negative 32. So I end up with x equals a negative 3.5 or x equals 0.375. Ta-da! All right, for number 3 here, for I got it, I want you to go ahead and pause it. I'm just going to let you know which method I would choose. So I'm not going to necessarily work these out. Maybe I will. We'll see. Once you press pause, work through all 3 of them, choose what method you would do, and why don't you go ahead and work them out just so you can have more practice with that. Pause. All right, for each of these, this is what I would choose to do. So for number 3A, really easy, factorable. Now remember, I can use the quadratic formula in any of these, but I'm looking at trying to be efficient with my time and strategize a little bit. So I can see on A that it's easily factorable. For B, I can see that there is no X term or B term or that middle term that we use. So I can do easily squaring this one, perfect square. And then for C, actually for B, I'm going to square root everything. Fantastic. For C, on this one, what times what? That gets me 1. Or actually, it's going to get me 5. That's going to get me to 13. Tricky one, so quadratic formula help me out with that one. That'll give me my solution. All right, well, I am going to go and take my pet lemur for a walk in the mall.